All right, here we go with 11.4 and 11.5, and I'm probably gonna have to make another video for 11.6 and then go over some examples. All right, so we're gonna look at volume of prism and cylinder, right? We looked at surface area yesterday. That's how much space is covered on the outside of an object. Volume is how much space is inside of an object. All right, so that's volume. All right, and so here's the formula for volume of a prism. Right, capital B represents the area of the base, right, of just one base, and then times the height. Right. Um, okay, so I skipped 1 and 2, I think, because I think those were a little bit on the easier side. Okay, so you can look at the notes on your own. Here for number 3, you notice this triangle here is just a zoomed in version of the small triangle, right? And so since it's an equilateral triangle, right? 3, 3, and this 3 here is the same as this 3. And so this ends up being a 30, 60, 90 triangle. That's half of it, okay? If the hypotenuse is 3, then half of it is 1.5. And then so therefore this is 1.5 root 3, okay? And so the area of this triangle is 1/2 times base times height. 1/2 times base is 3, and the height is 1.5 root 3, okay? But then the actual height of the prism itself is 9 feet, right? So that's the 9 feet here, okay? Here, number 4, area of the base. This is a trapezoid, okay? You'll have the area of a trapezoid formula given to you on the formula sheet. The height of the object is 9. So that's why this 9 is out here as well. For the units, don't forget it's cubed when we do volume, okay? Cavalari's principle. Um, so all this means, so like look at number 5, right? Read the principle first, right? And what that means is if you imagine a stack of paper that's completely vertical, right? But then let's say you take that stack of paper and then let's say you kind of push it so that it's leaning, right? Well, the volume doesn't change inside, right? And so that's Cavalari's principle, right? So if it was, if the stack of paper was standing straight up versus the stack of paper that's kind of leaning, right? The volume doesn't change, okay? And so, um, yeah, that's what Cavalari's principle says, all right? Volume of a cylinder, again, same idea, right? Volume of the base times the height. It's just that we are using a circle as the base. That's why it's pi r squared. And so the volume of a cylinder is pi r squared h. Okay. Um, yeah, again, I think 7, 8, 9 is kind of self-explanatory, right? For number 8, one thing to be careful of, um, 40 is the diameter, right? And so the radius is going to be 20. Okay, so don't forget to change to use 20 as the radius here. And then you have these composite figures, right? Composite means like put together, okay? And so the volume of the shaded, this taller one, plus this other one here, okay? And then you got to add those two together, all right? Here you have the volume of the box, right? This rectangular prism, that's the white one, okay? And then the volume of the shaded, that's half a cylinder, right? That's why we got to multiply by half, okay? All right. You got to be able to discern the measurements. The whole thing from the cylinder to the edge of this prism is 15, and if one edge is 11, that must mean the leftover is 4, right? That's how we got 4. Okay, so that's your radius. And then here, I believe the problem is like the volume of the leftover if you have a cylinder within a cylinder, right? Idea is you have the volume of the whole one, the outer one, right? The radius is 5 because the diameter is 10, and then minus the volume of the inner one, okay? All right, and so we're going to leave our answer in terms of pi. If it says to round, then you're going to use the pi button on your calculator. I believe we're going into 11, what's the section number? 11.5, the volume of a pyramid, okay? Very similar to volume of prism, right? Base times height, but it's, for a pyramid is a third of that. Okay, so 1/3 times the area of the base times the height of the solid, right? And so here, the area of the triangle, 1/2 times base times height, because that's the base, right? The area of the triangle is 1/2 base times height. And so that's 24, that's your capital B, and then the height of the object itself, the pyramid, is 12, right? Remember, the height needs to be perpendicular to the base, okay? And then over here, the area of the square. Now these, okay, now, so the 13 is the slant height, right? 10 is an edge, and so the 5 is from the middle of the floor to the midpoint of the edge, right? And so therefore, you got to figure out the height of the pyramid. So we're going to use Pythagorean theorem, or if you recognize this is a 5, 12, 13 Pythagorean triple, okay? And so the height is 12, all right? So again, got to be able to discern these objects here. So yeah. Here, again, area of a hexagon. This is a regular hexagon, okay? You know, you got to figure out the central angle and take half of that, figure out the apothem, all right? You got to find the area of the hexagon, right? That's this. Remember, 1/2 times ANS, okay? And then after that, that represents your capital B. That's why this is here. And then they gave you the height of the pyramid itself, okay? Look over number 4, okay? And then the volume of a cone, very similar to a cylinder, right? Pi r squared h was the cylinder, and so the volume of a cone is 1/3 of that, okay? And so again, I think these are kind of self-explanatory, okay? Look over these examples. Sometimes you might have to do some trig, right? We're incorporating some past ideas here and concepts, okay? Can't use Pythagorean theorem because you don't know the slant height here, right? So in this triangle, in this right triangle, 42 is here, 42 degrees, and so 6 is opposite and x is adjacent. That's why you have to use tangent, right? Tangent is opposite over adjacent. All right, so here's our setup. And if you multiply by, we kind of skipped a step here. If you multiply by x on both sides and then divide by the tan 42, that's how we get this setup here. Okay. And so sometimes you are going to have to use a rounded figure, all right, a rounded number. Okay. X is your radius, right? And so you plug that in here. Okay. And then sometimes you have to solve for a variable. If you're given the volume as 8 pi, right? So we're going to set up 8 pi as v and set that equal to the formula 1/3 pi r squared h. Now you notice we put slashes here through the pi because if you divide by pi on both sides, they cancel out, right? That's how we got this line right here. Okay, divide by 4 and we take the square root, right? So x is going to equal 2. We added this word symmetric because we're saying that the top cone is the same as the bottom cone, right? So that's why here we have the 2 cones, all right? So you find the volume of one cone, okay? And then you have to multiply that by 2, so that's how we got 49 pi. and then you need to find the volume of the cylinder. All right. Now the thing is, I think originally we don't give you the height. All right. I think you have to figure that out. All right. This 25 diagonal, you know this is 7 because if the radius is 3.5, then the diameter is 7. Okay, so that's 7 up here. And so if you don't recognize it's a 7, 24, 25 triangle, that's fine. You can do the Pythagorean theorem, right? 7 squared plus h squared is equal to 25 squared, and then figure out the height as 24. Okay. And so once you find the volume of the cylinder, you add it with the two cones. That's how we got 343 pi. Okay. Here, find the variable in each figure. Leave answers in the simplest radical form. Okay. So we give you the volume of each of those. Right. I think B and C are a little bit easier to figure out. Okay. For number 10, the base is a equilateral triangle, and so that's what we drew over here. Okay. And so if this is x, the hypotenuse, right, and this ends up being a 30, 60, 90 triangle, then we know that this side must be half of that x, and this must be 1/2 root 3 times x. So that's what this is here. Okay. So capital B is the area of the triangle, 1/2 times base times the height. Okay, the height of the base of the triangle, and then the actual height of the object is 6, so that's what this 6 is. All right. And again, since there's a root 3 on both sides, right, if we divide by root 3 on both sides, they cancel out. Okay. Okay. So yeah, I'm gonna make I guess there's another video. I'm gonna have to do 11.6, I believe, on another video. So I'll take a look at that one.